Hi everyone, welcome to the next video. In this video, I'll be taking one more example of the shortest remaining time first algorithm. Alright, so let's get started with the example. Alright, as always, I have not prepared this table and I have not prepared the Gantt chart so that I can make it in front of you and you can better follow it. Alright, let's start. So, this is the Gantt chart. At time t equal to 0, Gantt chart is starting. Alright, so your first process is arriving at time t equal to 1. So 0 to 1, there will be no process. Okay, there will not be any execution. At time t equal to 1, this process 1 is available. Alright, so what are the available processes? Only process 1. So now your operating system is having only one option to schedule, I mean only one process to schedule. Which one is that? That is P1. Okay, after 1 unit of time, that means time t equal to 2, your operating system will decide which process to schedule at time t equal to 2. Okay, whether to continue P1 or to take some other process. Okay, so after execution of 1 unit, okay, your process 1 is having 7 more unit of burst time. Alright, so at time t equal to 2, now we have two processes. And what are those? That is process 1 and process 2. Alright, now the catch is both of these processes are having the same burst time, that is 7. Okay, so now which one to schedule? P1 to continue or P2 has to be scheduled? Okay, so if your operating system decides to schedule P2 here, okay, then there will be a context switch. But if your operating system decides let's continue P1 itself, okay, then there will not be any context switch. So your operating system will keep on executing P1 only. Alright, so what will happen? P1 will be scheduled here. Okay, so one more unit, that is time t equal to 3. Okay, so even if you can see this line here, okay, I have drew this line so that I can explain you step by step process. But when there is P1 and there is also P1, so this is not a context switch. Alright, this P1 is executing. Okay, so at time t equal to 3, now you have, okay, what has happened is your P1 started at 1 and it kept on continuing till time t equal to 3. So there is no context switch. Alright, so now let's see what will happen. So now let's see how the burst time of P1 changes. So from 7 it has become how much? 6. Okay, so at time t equal to 3, now you have process P3 in your system as well. Okay, and now which process is having the least amount of burst time? That is process 3, because process 3 is having 2 unit of burst time, okay, which is the minimum among 2, 7 and 6. So now P3 will be scheduled. Alright, for how much time? For 1 unit of time up to time t equal to 4. Okay, so now how the burst time of P3 changes? This 2 becomes 1. Alright, now by the time you have reached time t equal to 4, in your system you have all the processes. Okay, that is one observation. Alright, so now if you see which one is having the least amount of burst time, that is either process 3 or process 4, because both of them are having burst time of 1 unit. So now if your operating system schedules P4 here, then this will be a context switch. But if your operating system keeps on running this P3, okay, then there will be no context switch. Okay, so what will happen? What will happen? Your operating system will keep on executing this P3 only. Okay, so P3 will be here as well. So this will be running till t equal to 5. So how this burst time of P3 will change? It will change from 1 to 0. Alright. So now let's see which process is having the least amount of burst time as of now. So that is process P4. Okay, now let's schedule P4. In the last video, I have already told you that the time when you have all the processes available in your system, alright. So now you don't have to wait at every unit time. Okay, whatever process you are picking, just pick it, run it till its completion and go to the next process. So what will happen? How much more time this P4 requires? That is 1 unit of time. So 5 plus 1 becomes 6. Okay, now this is 0. Now what to do? Now choose that process with the least amount of burst time, that is process 1, because it is having burst time of 6. Okay, so let's make it process 1. You don't have to wait at every time unit. Okay, so the moment you have all the processes in your system, it may sound repetitive, but I am repeating so that you can understand it much more better way. So the moment you have all the available processes, okay, whenever you are picking any process, you don't have to wait at every time unit. Okay, just pick it, run it till its completion and move to the next process. Why so? Please go back to my previous video. In that video, I have explained this part in detail. Okay, so what will happen? Process P1 will be running till its completion. So process 1 will be scheduled at time t equal to 6, and for how much time? That is for 6 more units. So 6 plus 6 is 12. Okay, this 6 has become 0. Now process 2 will get scheduled. Okay, for how much time? For 7 unit of time. So that is 12 plus 7, that is 19. Okay, now let's fill this table. I have already told you one trick. While filling the completion time, always come from this right side. Okay, so what is the completion time of process 2? That is 19. Write it down, 19. What is the completion time of process 1? If you see here, this completion time of process 1 is 12. Write it down. So I'm moving like this, moving like this. P2 is done, P1 is also done. Now P4. What is the completion time of P4? That is 6. Now come. What is the completion time of process 3? That is 5. Now let's come to turnaround time. We all know that turnaround time equal to how much? Completion time minus arrival time. Completion time minus arrival time. So 12 minus 1 is 11. 19 minus 2 is how much? 17. 5 minus 3 is 2. 6 minus 4 is 2. So now if I want to calculate wait time, I have already explained you that turnaround time is equal to, we can say, wait time plus burst time. Okay, this is a equation that we can follow. So now wait time will be turnaround time minus burst time. Alright, this will be wait time. So turnaround time minus burst time. So burst time as in the original burst time. So 11 minus original burst time, how much it was? 8. So what is the wait time? 3. So now 17 minus 7, how much it is? 10. So again 2 minus 2, that is 0. 4 minus 1, that is 3. Okay. So now let's come to this response time. What is response time? So response time is the time duration between when the process has arrived and the time in which the process is scheduled for the first time. Okay. So what will happen? Let's say at this time the process has arrived. Okay. And this time your process is scheduled for the first time. So at this time this process is preempted and some other process is getting scheduled. Okay. Then another process, then let's say this process is again getting scheduled. Like take me an example, let's say first P1 was scheduled, then P1 was continued. Okay. Then P1 was preempted and this P1 was again scheduled at time t equal to 6. Alright. Something may happen like that. But in response time, we will be picking this time window, and this time is the duration between the arrival and the first time when the process is scheduled at the CPU. So the arrival time of process P1 was 1, and when this process P1 was scheduled for the first time, that is 1. So what is the difference between 1 and 1? That is 0. So response time is 0. So process 2. So while calculating response time, always move from this left to right. When process 2 has arrived at time t equal to 2, when process 2 was scheduled for the first time, that is 12. If you see, 12 was the first time when process P2 was scheduled. So what is the difference between 2 and 12? That is 10. So when this process P3 has arrived at time t equal to 3, when it is scheduled for the first time? At time t equal to 3. So what is the difference between 3 and 3? That is 0. So when process P4 has arrived, that is time t equal to 4. When P4 was scheduled for the first time, that is time t equal to 5. So what will happen? 5 minus 4 is 1. Okay. So now let me calculate the schedule length. So what is schedule length? Let me find the schedule length. So schedule length will be maximum of completion time across all the processes, that is 19, minus minimum of arrival time across all the processes. So across all the processes, what is the minimum arrival time? That is 1. So 19 minus 1 is 18. What is throughput? Okay. Throughput is, okay, please bear with my handwriting. So throughput is number of processes by the schedule length. What is the number of processes? That is 4. Okay. Divided by schedule length. How much it is? How much it is? 0.22. Alright. So this is one more example of shortest remaining time first. Now I hope the shortest remaining time first algorithm is much more clear to you. Alright. Please let me know in the comments if not. So now let's move to the next part and last part of the video. So what do you think? What data structure you could have used in the entire algorithm? So if you see, every time you were finding the minimum burst time across all the available burst times. Okay. In such scenarios, which data structures we can pull in? So that is pause the video here, think for a minute, then come back and play the video. So that data structure will be minip. Okay. So if you are already familiar with the minip, then you know in such scenarios where you have multiple things and you will have to pick the minimum one, then minip is the right choice. And if you do not know minip, wait for few more days. Once I have my lectures in data structures and algorithms, then you will be able to understand what minip is. Alright. And if you cannot hold till then, you can go and search on YouTube. Many good YouTubers are there who have already covered this topic minip, which is a very well known and very popularly used data structure. See you in the next video.